Hello and welcome to Claigan's webinar on the IUCLID web interface. So we're talking about SCIP. So it's Bruce Calder here. I am the VP of Consulting Services at Claigan. We're talking the new prototype IUCLID web interface and entering SCIP declarations into the interface. Now we're going to also be talking a lot about the practical elements that feed into it. So quite a detailed agenda. A little introduction, which is going to go fast, and then I'm going to talk about some of the restricted materials deadlines for 2020 to 2022. Just a reminder of all the stuff coming up. And then we're going to talk the SCIP database. We're going to talk a little bit about, so this is for entering REACH SVHC data into IUCLID, which is the Substance of Concern in Products database. We're going to talk about the interface options. We're going to talk about the structure of what you put in there, the Excel worksheet that we work on, that we use, and then we're going to go through the worksheet and then an example IUCLID submission, so SCIP submission, and the dossier that comes out of it. And we're going to talk a lot about the workload or distribution of work. Then we're going to talk about a bunch of practical approaches, the component level declarations, how we handle them and why we handle them the way we recommend, solutions like engineering evaluation, testing. We're going to talk about cloning and how you clone your declarations for similar products and how that works manually and then automated. Then we'll have some Q&A. So the plan is the webinar is about 50 minutes and then about 10 minutes Q&A. Q&A this morning went on for a while, a lot of really good questions. There's a lot of stuff still in the air. And so one thing that's going to come up a lot in this is a lot of your information sources will often be people trying to sell you things. And they'll have a lot of motivation to steer you down the path towards their solution. Big recommendation is going to continue throughout is don't worry about uploading 100 products or 1,000 products or what we have. Do one. Just do one. Learn from that. And then get a better idea how you can do 100 or 1,000 or whatever. And you're going to find, in general, it's not so bad to do large numbers if you have the product level declaration. The REACH SVHC is the challenge, not the SCIP part. So we're going to go through all of that kind of stuff and explain it and all the different options, and also some Q&A. And there's lots of good Q&A. So first of all, regulatory deadlines coming up. A lot of stuff are coming up right now. The one people getting pinged with this March is EAEU ROHS, so as I see Russia/Belarus. ROHS, where suddenly people are in scope, their distributors or brokers are demanding a test report so they can submit it into the ROHS system. It's somewhat limited scope, but still quite a broad range of products. And they're definitely demanding test reports. Even though theoretically it's tech files, they're just demanding test reports. So big thing, EAEU, ROHS. A lot of people are having stop ship type problems right now. It's causing a lot of problems. And of course, the big one in May, the EU medical device regulation, MDR is kicking in, and then the PFOA restriction under REACH and potentially under POP eventually in July. And of course, the one we're talking about here is January 5th, 2021. It's a substance of concern database. And then middle next year is the phthalate restrictions kick in for ROHS for medical and monitoring control. And then a fairly big one for EU for the medical is the addition of cobalt to EU MDR. Cobalt was identified as a Category 1 officially published in the Journal of the EU in February as a Category 1 known to cause cancer, a carcinogen. Therefore, it's regulated under EU MDR in September of 2021. And where cobalt is a problem for medical devices is it drags in stainless steel. Most stainless steels have cobalt between 0.1 and 0.2%, which makes it, so unless the rules change, that makes stainless steel generally declarable and having to be justified for its cobalt content and labeled for its cobalt content under EU MDR. So it brings into regulation stainless steel in medical devices. So a lot of churn, a lot of work going on. If nothing changes, cobalt enters EU MDR, which basically stainless steel enters regulation of EU MDR to a certain extent by September of 2021. And then the end of next year or so, the new Canadian restrictions start to kick in. A bunch of new substances that aren't otherwise regulated are going to start being banned in Canada around the end of 2022. Still up in the air of the exact date. So lots of stuff, but today we're talking about the Substance of Concern database. So our services, of course, creating the product level REACH SVHC declarations, which is most of the work. Most of the work is identifying the declarable SVHCs in the product. We can do that by testing, and our test lab is excellent, especially for complex products. It's wonderful and very strongly recommended, in particular for new designs. For new designs, it's a lot easier for most companies when they get into the design phase and they're figuring out what electrical standards, what EMC standards they have to comply to. They just put the restricted material standards in there, and then coming out of pre-manufacturing, they need a test report for the restricted materials. Makes life really easy, dovetails in really nicely. But for legacy products, that's not always a possibility. So we do test also for a lot of companies representative products and use that data for larger product range. But the other thing, if you have also expensive, especially complex legacy products, even if you just want to learn or do one, is we come there and we do an education with you, a little bit of this, but a lot more specific. And then we do a hands-on engineering evaluation of your product with you. We show you the materials. Remember, this is a declaration, not a restriction. So we identify what materials are in your product, and which ones are likely to have REACH SVHCs. As long as we declare them, you're compliant. And you can choose to do the work once we identify, hey, this nitrile rubber can have phthalates, so on and so forth. If you've done the work to make sure there's no phthalates now in your nitrile rubber, then you can remove it. But it's very hands-on. We get to show, then we create the Word version of the declaration, the REACH SVHC one, and then the Excel version we'll show later for SCIP, which is the real working sheet for SCIP. And then we can do the IUCLID one, but you can create one, and it's very tangible, and you find the information a lot more portable to other products. Of course, there's the REACH SVHC declaration, which is most of the work, but we do create the SCIP Excel file. So we work in Excel. You're going to find, for practical reasons, you're going to do a lot of work probably in Excel. And it has a lot to do with you have a declaration for one product and then applying the similarity to another product, then how you identify safe use instructions. And you got to enter all the fields somewhere before you go into IUCLID. You don't really want a free form, get an IUCLID, and now we improvise. So most people, the way we do it is in Excel or Google Sheets, where we do the work first for the fields in Excel, agree upon it, manipulate it back and forth. See a lot of advantages of that. And once we're happy with it, then we make the IUCLID submission. You don't sort of freelance the IUCLID submission off the spur of the moment. It's much easier to do it from a structured concept in Excel. Get all the fields you want, all the products, agree upon which products you're putting in, what you're going to call them, customs codes, everything. And then it's pretty easy to do IUCLID. So what of course we're talking about is the substance of concern in articles as or such in complex objects products. Sure, SCIP. If you have a product that has a component with a REACH SVHC about 0.1% by weight of that component, the product and its component have to go into the database by Jan 5th, 2021. And what we're talking about is the prototype version of that database, which you can access now, and then the real versions in October. So I'm going to be a lot more specific about, it's also multiple versions. There's more than one entry portal. So we'll go over all that. So we're talking really about the web version. So this is a web interface, prototype interface into the database, which was released about a week or two ago. And then there's going to be a downloadable version available in April, we explained, and then the final versions are available in October-ish timeframe. But most of the work you're doing now will be easily portable to the final version. So there will be 3 different interface options to submit in the database. Option 1 is you have a downloaded software. So in April, this version will be available, the prototype, where you can download it on your computer, and then you can create the submissions there. And we generally have used the offline IUCLID system for chemical dossier submissions, which is the same system. It's a lot easier just to work it on your computer, double check it, review it, control it locally, and then upload it. The one we're talking about today is the web interface, which is basically a dashboard interface into the system where you can create the declarations and then publish them or upload them, even though you're already in the system. And then you can do a third-party software that can interact directly or semi-directly. Most of the time, they just create the file that gets uploaded. We find that's going to be problematic. We don't recommend going the third-party software route off the bat for sure. We definitely recommend first do one all the way through, and then do a whole pile, and then identify in the future whether or not there's some practical advantages for third-party software. Believe it or not, we can generally do the SVHC declarations and IUCLID files in the time and effort it takes you to negotiate the software contract. Like, it's just do the work first, then figure out what's the best way to optimize it. You can do, but create one, then look at doing a whole range of them, and then long term, you can say, okay, now I know something. I'm not dependent on the person who wants to sell me stuff on their opinion, because they want to sell you stuff. They have a commission. You got to realize that we're all like that. Actually, one neat thing you'll notice, we don't actually have salesperson people here at Claigan. It's a bit of a weirdness. If you talk to somebody about anything, it'll be somebody who works in the field. You'll be talking directly to somebody who does this, usually in engineering. But if you talk to somebody doing at Claigan about stuff, about your project, it's always going to be somebody who works on it. So it's a little bit different. So we're going to create, I'm going to take an example product. Now, this is a pseudo make-believe product. I literally put Mixer into Google. I found one in Alibaba that didn't have a brand name, and that's what this is. So it may look like somebody's product. It is literally an Alibaba product with no particular brand that I put here. So because this product fictitiously and very likely has lead and brass components, so it's lead and brass, which is a declarable SVHC, and has D6 siloxane. So silicone is made from the siloxane monomers, D6 being one of the most common. Generally, the D6 will be 1% of the weight of the original silicone before it's cured. And once it's cured, it's around 1,000 ppm, give or take. So D6 is often above 1,000 ppm in silicone rubber, which makes it a declarable SVHC. So we're saying this product has to be in the database because it is lead above 0.1% by weight in the, say, standoffs or the mixer main shaft there, or it has D6 in one of the silicone parts above 1,000 ppm, which is pretty darn normal for food contacting product. Now, consumer products in the system have to be specific to the point where they basically are at the UPC code, in Europe called the GPC code. It's called GPC code, even though it says right next to it in brackets, Universal Product Code, GPC, which I don't understand because Universal starts with a U. But it's a GPC code, 012345678905. Obviously, make believe. It is literally the Wikipedia example for a UPC code. So consumer products have to be product specific to the point where the consumer can pick up the box, turn it over, and see a serial number or UPC code and relate it directly to the entry in the database. So legally, the database is for the waste providers with a caveat that consumers will get access. It's for consumers. It's built and structured for consumer access. So it has to be that the person buying the consumer product can flip the box over or the product over and look at the serial number or UPC code and go to this. So it has to be that specific. Now in practice, we've talked about we make generic models. You can make a general model, but if you have 5 different UPC codes, you have, and even though they might use the same declaration, you have to clone them, and we'll explain that to 5 different ones. Cloning is not hard at all. Making multiple declarations, if you know what SVHCs your products have, it's not a big deal. Professional products have a little more leeway, but they still have to be specific as appropriate. Now, and a lot of professional products will have one serial number that can have custom or additions to it. That's okay. You just list it under one. I mean, you can take a Dell computer, for example, and it can have different things inside, but the main computer is still the same SKU. So you will have products that can have additions to it, and it's interesting how they handle additions. So, for example, if we have even medical device, handpiece, battery powered, it'll have a SKU for it. And it'll have different SKUs for different lengths. And of course, they need different listings, even though they'll be identical. So you just clone one and the other two. But they can be sold with a battery charger. And the battery charger is a different SKU and will often need to be, if it has an SVHC and any component above 0.1% by weight, will have to be in separately. And so there's a lot of complications like that. But the first thing is once you know what SVHC is declarable in the handpiece and what SVHC is declarable in the battery charger, this is straightforward. So we're going to talk about this particular one. You have to enter its UPC code for consumer or similar, serial number, etc. Model number is not sufficient in of its own unless it's unique and there are no other sub-UPC codes under it or SKUs. And then it's customs code. It needs to have its customs code. This is now, the nice thing about the customs code, people have been concerned, oh my goodness, there's a different 8-code customs code for the same product in Europe versus North America. The nice thing about it, the 8-digit ones are there, but so are the 6 digits. So you can scroll back like this one to the 6-digit number and use that. It's a pull-down menu. It's wonderful. You just pick it. You start typing in 85094. It starts coming up with the options, and you pick the one that's appropriate. So we have to create a listing for the product and a listing for each one of the components. And so the leaded brass, 1 to 10%. That is safe use instructions for physical contact with brass. You have to say what material it's in, which is brass, which is copper brass. It's in there twice. You have to say how many instances are in there. However, if it could vary from unit to unit because you don't necessarily control it that way, we normally just recommend putting a passage in there saying this declaration is for a represented product. Individual units may have more components or less than listed below. And then there's a silicone seal because it's D6. It's a thermoset silicone. We say there's only one of them, and it's safe use instructions around bioaccumulants. They're not worried about human contacting, they're worried about disposal. So this is structurally what we're going to put in today. The way we do it first in Excel or Google Sheets, and you find that you're going to get a lot of declarations into being similar. You may change what you say about themselves. You'll probably get a lot of copy paste actually. So it's the name of the article. You can call it whatever you want. There's actually 2,000 characters available in that field. I'm not sure what you're going to write there. 2,000 is a lot, but you can. And then there's 2 IUCLID IDs. One for the company, which doesn't seem to be any restriction to the company. We have people here that have created their own IUCLID ID. It's a big, long super string of like 30 or 40 characters with letters and numbers and dashes. And it's not something that you'll remember off the top of your head. It makes a Wi-Fi password look pretty simple. And then when you put the product in there, you're going to get a product IUCLID ID, which is, again, another 30 or 40 character string of stuff, gobbledygook. And if somebody asks for your listing, you'd provide them that, we'll say number in air quotes, because you'll see some in a bit. It's a bit exciting. Something you want to put in like a spreadsheet because there's no way you're going to remember it offhand. Then you have to put its unique identifier, which we use the GPC code here, otherwise called the UPC code, but it could be the serial number. And so for the finished product or final products, we put very specific. Here's the GPC code, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 5. It's customs code. You should pick this one. Is it produced in the European Union? Where the options are yes, it is. No, it is not. And then the other option is withheld. We're not going to tell you. Then you put the safe use instructions, and because, as you will see in a moment, we keep the SVHCs completely at the component level, and the finished product will have no SVHCs directly in its listing, it's in the sub-listing of the components, we say C component safe use instructions or safe use instructions not required at the finished product level. Then we have a field, not this one, where we usually say something honest and truthful. We probably even add a sentence saying the representations here are to the best of our ability, details of our representative model, the numbers of components of the SVHCs may vary from unit to unit. And as long as the idea is to be truthful, you say, hey, this one has 2 leaded brass components, but realistically, we allow the 6C exemption in our products. The next one could have 3. Even though they're all the same unit, the next bill could have 3 if we use a different supplier. We don't control it that way. Even the supplier is providing us a pump. We don't control it at that level. They may have more or less. So let's be honest with them, saying if we say 2 here as brass components, you know what, it could be slightly off. The nice thing about it is the SVHC legislation is not specific about that numbers. You have to identify the article, brass component, in the SVHC, lead, which we'll do in a moment. But this part of it is for the database. And you just want to be honest, and if there is a potential range, you just want to say something about it. And then we have the silicone seal, which is the linked article. So again, the lead is not listed in the mixer. It's listed in the linked component, linked article 1, and the silicone seal is linked article 2. And you see a bunch of other linked articles, which then shouldn't be silicone seal twice here, but there it is. And the way we do that, and you notice they have 0 instances. We don't enter those in the database. What you're going to find is the number of SVHC containing component types is actually fairly limited. And in your products, even more so, be very repetitive. So we normally end up listing them, and then for each product that has them, we just identify they have 1 or more of these. And so it allows a lot of them to use the same base data sets, like the brass component, the generic brass component, without worrying about trying to manage all these different unique parts. Some people are like, well, why don't we just link it to our supplier's part? Oh, goodness. 87 different reasons for that. First of all, that means they have to have their declaration in, all your suppliers have to have their declarations into the system before you do. B, it tells everybody what parts you're using. C, you can't use alternative parts. D, you're completely dependent on your suppliers updating their information. E, one of the biggest ones, if you put a specific part, subpart in here, that means in your new part or your part change process, you're gonna have to have people double check their SCIP listing every time they wanna make a part change, as opposed to the generics, which is gonna really, I mean, the new part change process is bad enough without adding that in, or people might just ignore it, which is probably worse. And you're going to see a whole bunch of other reasons why you don't want to normally put your supplier part in here. When you update the listing here for the brass component, you want to do it at the brass component level. You don't want to have to update every single product that has a leaded brass component. So we'll show you a bunch of examples. So this is the Excel version of the product, and we generally do one in each column. And where you're going to find at a certain point in time is I made a mixer here, and it turns out that the green, red, orange, blue versions are different GPC codes, which have different listings, but they're identical for this purpose. So we just copy them. And when we put them in the system, we clone them. We either copy them or we identify in a different Excel that the Acme mixer all applies to all these different SKUs. So we know what to clone. But we work in Excel. And Excel doesn't limit you in the fact you can't change things. So we go back and forth and we do all of the work on the declaration here. We work on the fields here in a structured column row approach, a lot easier. And so that was the finished product. Here are the components, which basically says, hey, they'll eventually get their own IUCLID ID. They'll get, now we put here a part number instead of serial number, and it's your part, so you can call it whatever you feel like. So you can say part number internal. Some people might say, hey, we have a saleable version of this, like where you can sell a repair part. Awesome. So what you do in that case is you create the UPC code, a separate listing, clone of this, not even clone of this, sorry, separate listing for the separately saleable part, and you have it not have any SVHCs in it, you have it reference this component. So again, even when you change this, it not only changes the product, it changes the saleable item. Just a lot. If you have repaired parts, hey, we can sell a separate power cord and the brasses and the prongs. Why don't you just have it point to the same piece? So when you update it, or say, hey, we can sell the brass standoff all by itself for the silicone steel. Great. Then you create a listing for that particular SKU, and then you get also then have it referenced here. One of the reasons why you reference here, I'll explain. Why use generic components? So it has the part number, which you can make up yourself because it's internal. It has the article category, the customs code, which you put here. Is it made in the EU? If it's generic, we say unwilling to disclose because it could be from anywhere. Then the safe use instructions. The one we have here for lead is based on the physical contact leading to lead coming off in your fingertips, touching food or mouth, and ingestion. These are the warnings around ingestion and disposal from the lead chemical registration in Europe. The silicone steel is different because siloxane, D6 dodecamethyl cyclohexosiloxane, just rolls off the tongue. By the way, in terms of rolling off the tongue, if you're at your desk right now and you have like moisturizer nearby because it gets dry, especially here, it's really cold, and you take the moisturizer and flip it around backwards, and you might see in the ingredients dimethicone, which is the fancy name of saying silicone rubber, or you'll say the D5 will be either pentamethyl cyclohexosiloxane. So the way most moisturizers work, not all of them, but virtually all of them, or hair conditioners, is they no longer moisturize your skin. They actually coat your skin or hair with silicone rubber. And silicone rubber allows, believe it or not, allows air to go through, but not water. So they don't necessarily moisturize. They just seal the water in by coating you in silicone. So this ingredient is actually usually in your moisturizer. So if you have moisturizer at your desk, feel free, or in your bag, just flip it around. You'll probably see at least dimethicone, which is a fancy word of saying liquid silicone, which is D6 or D5. You might also see pentasiloxane, which is D5, which also REACH SVHC. So they're not harmful to humans. That's why they're great in moisturizers to a certain extent. They do not react with you. Neither does your kitchen spatula. And one of the reasons they choose silicone rubber often for food, even though it sucks up oil, it doesn't interact with the food. However, it's non-reactive. So when the siloxane monomer goes down the drain, the fish can't process it. So that's why it's a bioaccumulant. So its warnings are not about ingestion because it's not poisonous. It's benign. Silicone doesn't do anything. However, it bioaccumulates because the environment can't process. So its warnings around do not mix municipal waste, do not flush or pour down the drain, which would be exciting for silicone seals, but I guess you could flush it. Okay, so after the safe use instructions, which are things you have to decide upon, there's no set. This is not a pull-down menu. This is free-form text. The next one is a pull-down menu, candidate list version. It's the most recent SVHC list you reviewed to. And by January 5th, 2021, you will have to have reviewed the 2020 January list, the current one, the one today. So you have to be up to this at least by when you do the submissions for next January. So as a pull down menu, we're saying we reviewed this part to January 2020's list. It has lead in it, which is a pull down menu. It's a pull down menu that we check between 1 and 10% because lead's around 3%, but there's 1.1 to 100%. And then you have to see what material it's in. And the brass materials, metal dash brass. It's one of the pull downs. It's a pull down also. Now, one of the reasons why we have the candidate list, why we also do it as generic components, if you update this to the July 2020 list when it comes along, you update it here and it repopulates to the finished products. There's a little bit of complication about republishing, but it populates the finished products. As opposed to if this data was in the individual products, you'd have to, when you say, hey, I've now reviewed it to the July 2020 list, awesome. Now you have to open up every single SCIP declaration. We'd rather open up the handful of generic part ones like this and have it populate out to everything that uses it. It's a lot easier. So we do this Excel version, a finished product, and then the component level. And there's the brass component and the silicone seal. So that's awesome. That's the Excel version. That's where a lot of the real data work goes. Now we're going to talk about the IUCLID version, the exact same thing in the web version. So the same fields. Now there are 3 different ways to interface with the web, and we talked about this before. We're going to talk about the interface with the SCIP database. There's a software you'll be able to download in April, the prototype version. The web interface we're going to talk about now, and you can have a third party. There's third-party developer software to interface directly. We wouldn't recommend that off the bat. Definitely not even the second thing. First thing you do, create a declaration, create the product level declaration, create the Excel version, create the IUCLID version, learn from it, go, okay, now how I'm going to do my products, do it mostly manually. There's a couple things we'll show later about mass cloning. And then if there's an efficiency in the system, probably won't be actually, you can look at third-party software, but don't start there. Start with creating one, then creating all of them, or at least a product line, and then figure out what's the most efficient way. So this is what it looks like. We've created one. It's not quite the fields, but it basically says this is all the fields basically enter. We'll talk about, now this is really small print, and so as you're getting older, like I unfortunately am, you might have to get closer or take your glasses off, or if you have glasses like mine, which are a little bit different if I look through the bottom, you can make some of these letters. Actually, one of the worst parts about, of course, getting older and this things is for the problem with close vision, is you look really closely. It makes for a lot of excitement when catching a fast football. It's pretty clear right up until the end, then you can't see it and it goes through your hands and gets you in the face. Not that it's ever happened a couple times, but maybe. Anywho, so this is the Acme mixer. And you can see in the top left, as I pop it out here, here's the structure. We created the finished product, the mixer, and then the individual components, silicone seal, brass components. And you see one has the other 2 in it. And they're basically separate items, and one calls the other items. So that's basically the structure. So the structure, as it buzzed through, we're looking here. This is sort of a nice visual representation. And then we looked at the Excel versions. This is the IUCLID version. Pretty simple, all the same thing. So again, this is what we're looking at. We're looking at the mixer that has a brass component and the silicone washer, which we just saw there. And so this is what the product looks like. Acme mixer. You have to put a name. You can put up to 2,000 characters, which I don't know what you'd be doing with that. You can put other names for it. You can call it a variety of other things if you felt like it. And I guess if you had different names for it in different countries, in one country it's the Acme mixer, the other one it's the Acme super paddle, or whatever you want to call it, different languages, you can do that. Then you have to have the mandatory field is the primary article identifier type. So it's a pull down menu, which we chose GPC code. We can choose serial number or part number. It's a couple other things. And it has to be, for consumer products at least, something where they can pick up the box and relate the box or the product to this listing. And so we're saying GPC code, which is Universal Product Code, which for me seems like UPC, which is odd because it says GPC there, but then it says Universal Product Code. Anywho, these are the people that created this. Maybe the same people created the SCIP Database acronym, or REACH, which has a second R in it partway through. For most people know the acronym. It's all odd. So and then the UPC code, which we took the Wikipedia example one, 012345678905. It's interesting they chose 5 there. And then other identifiers. Now, we might put this in characteristics. We'll generally put a statement, probably in characteristics, not article identifier, saying details of a representative model. The number of components of SVHCs may vary from unit to unit. And we're still having some discussion on where we're going to put that. And the idea is not mandatory, but if we think there could be variation, be honest and truthful. Say there will be. It's a lot easier to be a national authority. Like, look, we believe there'd be 2, but we said, there could be 3 of these. We didn't want to lie to anybody. We didn't want to mislead. We want to tell them the truth. The article category is mandatory, which is the customs code. Down below that is mandatory. Production in the European Union. You can say, yes, it is. No, it is not. Or withheld, i.e. we're not telling you. Then there's characteristics you can choose to add. You can put pictures in. You can say it's blue. You can say it's size. You don't have to, though. So we didn't. Then safe use instructions. We don't recommend having the safe use instructions at the finished product level because the SVHCs are at the component level. So we keep it there. So we said, check, no need to provide safe use instructions beyond the identification of the candidate list substance, the SVHC. You can add disassembly or treatment instructions, which are required under WE, but not required here. You could put them there, but you don't have to. It gives you the option to do so. And then someday in the far distant future, I can see if WE gets recast, them having to go in here. Until then, they don't. Then what components are in it? What complex object components are in this one? We said silicone seal. Article 1 has 1 of them, and Article 2, which is the brass component, has 2. And that's the finished product. There's no SVHCs listed here. It lists the article, the silicone seal, and the brass component that have them. So they're basically 3 separate listings, of which there's a hierarchy where the mixer calls those 2. And then you get another product that calls the same 2. So we'll take a look at one of the component ones. It's calling the brass component. Here is article name brass component. It's an internal component. You're saying primary article identifier type part number, and it's your part, so you can call it whatever you want. You just make up a number. If it's separately saleable, you may have to have its UPC code or similar, and what you do is you create one for that UPC code that points directly to this generic component. So that means when you update this generic component, it updates all the finished products and saleable replacement parts that use it. So you can be pretty darn consistent. Other article identifiers, you can give it other names. Down below it's customs code, one for brass components, pretty generic. Is it made in the EU? Well, it's generic, so we say unwilling, because it could be, it might not be. Pictures, you can put pictures if you want to. I wouldn't. Safe use instructions, we do put it here. So we have the leaded brass saying, avoid prolonged direct contact with skin during use, wash hands after contact, keep out of reach of children, do not mix municipal waste. Which, strangely enough, is, you take a look at the coronavirus, it's not that different instructions. So what we know from Prop 65 and from the EU registration, the main lead exposure for normal humans is touching of leaded brass or leaded ceramic, and it comes off in your fingertips. And people generally often don't wash their hands before eating, and about half of what ends up in your fingertips through hand to food or hand to mouth contact gets ingested. And that's how you get lead exposure or phthalate exposure or coronavirus exposure. Even though it's a totally different thing, it's the same sort of stuff. It gets in your fingertips, and about half of what you ends up in your fingertips in your day, if you don't wash your hands, ends up being swallowed by you. There's a whole bunch of EPA tests and studies and dynamics, but on average, about 50% of what gets on your fingertips, if you don't wash your hands, ends up ingested by you. So that's why the warnings here are about washing hands, skin contact. And it's not skin contact that's going to go through your skin. It's just going to get on your skin, and then you're going to touch your food or something else and ingest it. Concern elements, we said candidate list version. So not what version list lead is on. We said we reviewed this one to January 2020, or the first list of 2020, and it's got lead in it. It's a pull-down menu, and you can actually have more than one SVHC. So this says SVHC 1. You could have SVHC 2. So here's SVHC 1, lead. It's between 1 and 10%, which is a pull-down menu. What material category is it? The brass is metal brass. It's one of the pull downs. It says mixture category, but it's obviously a material, not a mixture. It's not a bucket of chemicals. So it's just material category. And if we had an SVHC that had more of them, we just keep tapping. You can also have one later on in life, you can update and say it no longer has SVHCs. We've gotten rid of all the lead in our brass components. We can click that off. One of the reasons, also one of the many reasons we use a generic component is, imagine in July of this year or later, you update this part and say, hey, it doesn't have any of the new SVHCs. Now up to date to the July 2020 list. Awesome. And then this propagates to all the parts that link to it. You may have to republish them. That's still not clear. But basically, you update this, it updates the listings of all of them. If you keep the SVHCs any higher, It means you have to open up all the different products, which is painful. So you just do it at the generic component level. Even if you sell brass components, we normally have the brass component SKU then point to this one. So when you update this, the separately saleable SKU gets updated too. It's a lot easier. So when it gets published, it ends up being two things. It ends up being like a PDF called a dossier, and I'll show you the PDF version. It also ends up being an IZ6, or for other people, IZ6 file. And if you ever get if you make an IZ6 file, put it in your computer, and if you want to know what it looks like inside, rename the IZ6 to ZIP, ZIP, and it'll open. Repackaging is actually modified. Repackaging is not that simple. It's just rezipping it. There's a developer soft instructions how to do it. But if you want to look at what's in the file, the IZ6, just change the IZ6 to zip, and you can open it up, and you can see all the different files and data in there. And it also not only has what you put in there, it carries the entire data set of declarable chemicals and customs code, and that's why the file is so massive. But there's two. There's an IZ6 file, and there's this PDF. And so this is what the dossier looks like. What we just built for the Acme mixer, here it is. And the UUID is who put it in. So this would be Roman. He does great work here. And you can see the UUID for Roman is something else, 734AB96. It just rolls off the tongue. So that's his ID, I believe. And then the dossier ID of this mixer is the AF2ED. So if your customer asks, hey, or authority saying, which is the listing for this one, you go, no problem. Here is this number, which you just do from memory. Or hopefully have an Excel sheet and send to them, because that's a doozy of a number. And then when data was done, and you see down below is the Acme mixer, use GPC code 012345678905. All the stuff we just did, here it is. And then it links to the silicone and the brass component, silicone seal and the brass component. And then in the dossier, it will then also publish, it will show the next sheets will have the silicone seal and the brass component. It's great. Just publishes. You basically take the one object, links to the two lower objects, and you push publish, basically, and it creates the file. Now, there's like so many people have been stuck on, oh, I have to upload this stuff in IUCLID. The uploading in IUCLID is easy. That's why we recommend doing one first. Go through. The most of the work will be actually identifying the SVHCs in your product. So it's so many companies are like, oh, okay, we can do this. They're like, can you do a SCIP declaration? Sure. I just need your product level REACH SVHC declaration. Oh, I don't have one. Well, it's mandatory, actually. You can't sell a product in Europe right now if you don't have an SVHC declaration, unless your product has no SVHCs above 0.1% by weight and components. You don't need to have a declaration if you have no SVHCs. But any complex product has SVHCs. Lead brass alone, let alone D6 and silicone and the EGDME and button cell batteries and so on and so forth, the high temperature solder and diodes and so on. So most of the work is identifying the SVHCs per product. If you have that, say a Word version we start with, then the next hardest one is creating the Excel version, creating the actual declarables and then agreeing amongst yourself at different stakeholders, different things. We like the Excel too. It also gives other business units a target. Yeah, this is what you need to fill out. You can do it any way you want. You just got to fill this out. We can help you, but you have to fill this out. And then maybe 10% of the work, in most cases a lot less, this is being a little bit pessimistic, is actually submitting to IUCLID. Well, I have 1,000 products. You're probably going to do cloning, which we'll show later, where if you've created, the hard part is actually creating the SVHC declaration in the Excel version. Once you have the Excel version, they're either A, very similar and you can clone them, or they're quite different and they would have taken work in the first place. But most of the work is declaring the SVHC, especially as you get to a complex product. That mixer has a couple declarables. If I have something that's got over a couple thousand parts in it, it might have 6 different declarables, maybe 8. The work putting in IUCLID is not significantly bigger. And especially because you keep reusing the same subcomponents, you're just going to end up relinking to it. And the IUCLID files are straightforward. As long as you have the data and what your SVHCs are, and then you create a good structure in Excel to work from. A lot of people are like, well, I have 1,000 products. That's going to be a lot of work. You already need the SVHC declarations. Now, for somebody, say, makes resistors, say RK73 resistor, imagine had lead solder in it. And even though they're all identical, there are different sizes and tolerances of these resistors. So there's, well, I don't know, 300 SKUs of the same part. So what you end up doing is you create one in the system and then you clone into the other part numbers. It's pretty straightforward. And we'll talk about cloning later. So Why do we do SVHCs at the component level? The SVHC is declarable at the component level, but why do we use the generic? It's simpler while being accurate and truthful. It's actually much easier for the customer to say it's the brass part as opposed to it's part 572. They'd be like, what? It's much easier for them, and it's accurate and truthful, and much simpler for you. It's better for your customer. It's better for you. The general descriptions are much more useful, and in a very practical way, when the SVHC list is updated, the updates can be made at the generic component level. I can update whether if I'm adding an SVHC or not adding an SVHC, I'm just saying I'm now updating to the July list. You can make one update and propagate it to all the products instead of opening up every product and updating it. And then if it's also based on supplier components, you can't, if you have to replace them, you'll have to enter that as part of your new product change process to double check whether or not it's already in your SCIP. And then you're completely dependent on your suppliers making the updates. And you have to, now you have to also get on them to make sure their components are updated, which means you're going to have to keep a list of all your products, all the declarable parts used from suppliers, and make sure you follow up with them to make sure they're up to date. Wow, this sounds like no fun. You can do that. It sounds like a make work project. We'd rather use a generic part. We update one to update many. We're not a big fan of make work projects, especially when it just makes it more complicated for everybody, including the user. Does data gathering work to create SVHC declaration of the product? No. No, what we used to do our data gathering for each SVHCs, we just got tired of the fact it doesn't bloody work. What the supplier data we get is just not right. It's not complete. Most of the components that have SVHCs are not, they don't have data. There's tons of things on people's bombs that are actually REACH SVHC declarables that are not even on their bomb. Our favorite, and probably the biggest recall problem in Canada right now for all products, are twist ties. You buy a power cord, awesome. It's got a twist tie on it. They're like, oh, what's a twist tie? Plastic. It's actually flexible PVC that uses phthalates and short chain chlorinated paraffins. The SCCPs are banned in Europe and Canada and are a recall problem. And the twist tie for the power cord that you buy separately is not even on the bomb. So we're not a huge fan of it. Well, we work with hundreds of companies. We do, we test, hundreds of products a month. We know what we've done lots of work for, we do lots of consulting, gone a lot of on-sites. We've almost never seen product level SVHC declarations complete and accurate from data gathering, especially not complete. We go to companies, hey, do you have your REACH SVHC declaration? Oh yeah, we have data in our database. Awesome. Do you have the product level declaration? No. Now, there's about 2% that are different. About 2% of the time people use data gathering and have it. They're almost exclusively food contacting products, and they almost always have a supplier spec that's mandated it from day one. So before they buy the part or have somebody make it, they say, hey, this is what we expect from you. It goes a lot better. We're not a big fan of after the fact data gathering. Just doesn't work. So if you want a part to be something, you should tell them before you buy it, because they're a lot more motivated economically to actually do something about it if you make it part of the specification before you buy it. A lot of times you go, do you have any, this chemical or that chemical in your product? They're like, well, if you asked about that before you bought it, we could have actually probably, done something about it before we made it. But we don't know because we've made it already. We can talk about it next time, but it's not helpful. So a lot of the best after the fact large scale data gatherings is an expensive waste of time for REACH SVHCs, let alone it's pretty junky for ROHS for the most part. ROHS, the only bonus is a lot of companies have made things ROHS compliant already. We still get tons of ROHS failures, and ROHS is much simpler to understand than REACH. I mean, we will literally have tons of questions after this from wonderful people like yourselves who are actually very knowledgeable in the subject with some confusions about REACH SVHC and SCIP and all the good things in life, which is perfectly fine. And you guys are, by and large, experts in this field. Down the chain of supply chain, they aren't, by and large, and you're going to have some excitement. So relying on them for REACH SVHC data exclusively, well, it's an exciting approach. So we're a big fan of supplier specs, though. Tell them what you're expected of them. And then, so for REACH SVHC, engineering evaluations, excellent, because this is declaration where we can review your products with you and show you how to do it. And so you can create product declarations. Normally, we can create product declarations in the time and effort it takes to negotiate a software contract for you. So it'll be done. It's just a lot more effective. Testing was fantastic. Our lab is incredibly experienced with complex products. We do it all the time. It's great. Not necessarily as viable for legacy products that may not have the budget. Usually, It works fantastically for representative products. We use it more for the regulations that are restricted. So if you test one and it passes, it shows your process is working. So if one of the products in one of the builds has a non-compliance, which human error is a big problem in this industry, there's really no penalty because you've been doing the proper testing. When we go to national authorities, if you have a non-compliance event, they will ask you, have you tested anything? And they say, well, you say, no, my supplier said it's fine. They won't care. Honestly, won't care. Their supplier said it's fine. They're so used to dollar store type products where the supplier always said it's fine and it's not. Unless you've tested a representative value of product compared to your sales, if you are compliant, they don't care how you've done it. If you've done data gathering and the product is compliant, awesome. If you've done data gathering and it's not compliant, the data gathering won't help you from the enforcement authorities. They might help you that you have a plan, but unless you've tested, they don't care. But if you're compliant, doesn't matter. But if you're non-compliant and you didn't take the effort to test and you believe the supplier declarations, they don't have a tremendous amount of sympathy. So what we do, and we'll get back to this, we're going to talk about a whole bunch of practical stuff again in a moment. We create product level REACH SVHC declarations, which is most of the work we do through testing, or we do it through the on-site engineering evaluation, which is really popular. We come to you, we spend like an hour and a half or so explaining the rules and what materials have it and how that all works, especially for other stakeholders who are not necessarily up to speed as you. And sometimes it's really worthwhile to have somebody who isn't you saying the same thing you say to your company all the time, really handy. And then we create the declaration. Wow, it's really, SVHC is not there most of the time. So that's not the best line. I'm not sure where that came from. But when do the on-site, I gotta fix that. So when you get the new slides, so everybody who registered will get a copy of the slides with that line corrected because it's not supposed to say that. So on-site engineering evaluation, we create hands-on with you evaluate the products for what can be in it based on the materials and create a product level declaration from that. Then we create the Excel version with you, and then it's easy to do the IUCLID. Once you create the Excel version, the IUCLID version's excellent. Now, we can create IUCLID versions for you, but what I also do, which we find even more effective for your long-term maintenance, is you do the submission, but we web meeting in and watch over your shoulder. As you get to each field, we say, yeah, that's actually what they mean. When you pull it down, this is, the customs code pull-down menu is enormous. Massive. So what you really do is you start typing in the first couple of digits of the customs code and it refines it down to the handful that apply, and then you click it. It's a lot easier. So we just do it over your shoulder. The other thing you're going to find in the systems is got a cloning capability, which another thing is called copy paste. So if you create a declaration, you can literally push a button, clone it, and add a new part number. So you say, hey, look, I have 5 mixers. I have the blue, the green, the orange, and the teal. You create the one for the orange one. And then which has 1 part number, and then you clone it for the other 4. And all you do is you enter the new part numbers because they're all the same declaration. And Bob's your uncle, which funnily enough is true in my case. Bob's your uncle, and you have 5, and you say clone, 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 and enter the part numbers. Now, mass cloning, we're putting a system together, mass cloning, and we won't use it very often, but this is a case, say, if you're a resistor or capacitor manufacturer and you have the same capacitor in 300 different sizes and tolerances, but the exact same declarable. We basically just take an Excel sheet of all the part numbers and mass clone it. And what it does is it opens up the IZ6 file, changes the things it has to, and then mostly rezips it up. There's still some details about how it renames the file in IUCLID numbers, but basically it's straightforward to mass clone. You don't really need this for very large numbers of SKU, the exact same thing. Generally, the manual entry and the manual cloning is really easy. Remember, the work is still heavily uncreated in the REACH SVHC declaration. That's where the main work is. Next one is creating the working version, or we use Excel or Google Sheets. Once you agree upon what you're saying about yourself, and we normally do it in column form in the Excel, because then you put a whole bunch side by side, and you can copy paste, and you can just make a different decision of how you can declare things. It's just a lot easier to manipulate. We use Google Sheets generally over Excel because if we're doing something like that, it's usually multi-stakeholder, and we don't have to worry about revision control as much on the Excel sheet because in Google Sheets, it's everybody's access, and you don't have to worry about who's got the last version. And then you submit it into IUCLID, which we said, 10% of the work is probably a lot less. We're assuming that there's a lot of manual complexity in your products, but a lot of cases it isn't. And especially as you get to super complex products where the effort of finding the SVHCs is a big job, but submitting is not much different than the electric mixer. Like, you know, you have an air conditioner for a hotel, which is massive, or a metal detector for an airport. That's a big machine. It's SVHC declaration. They usually have quite a few declarables. So that big, huge machine takes about twice as much effort to put in IUCLID, maybe. The effort of getting all the SVHCs, though, is quite a bit different. But putting in IUCLID is not a big deal because it's just, so instead of 4 different declarable type of parts, it is 10. And that's it. So what we recommend, the phases to SCIP compliance. Create a declaration for one product. People try to sell you things. This is how you do 1,000. This is how you do all your products. Don't start by doing all your products. When I'm cooking a cake for the first time, I don't go, okay, what I'm going to do is I'm going to set up to cook 100 cakes, and one's going to be a mousse, and one's going to be cheesecake, and one's going to be classic pie. I'm going to do them all at one time, and this is how I'm going to start. No, I got to cook one, figure out how I'm doing, and then think about what's the best way. Well, probably not. Doing 100 cakes is just a bit intense. I do one first. Do one first. Learn about it. You will learn things going, oh, and long before you make big plans. Then you need to develop the REACH SVHC declaration, the product level. Don't worry about what goes into the system yet. You still need to create the deck, which is mandatory anyways. So testing works fantastic. Might not be viable in all sorts of situations. Hands-on engineering review is excellent. It's the fastest way to create a declarable. Remember, it's declaration, not restriction. You don't need to know if it's in there. You have to know if it could be in there and therefore declarable. Then you put a caveat saying, you know, the number of parts with the SVHC may differ, but you declared the article and the SVHC, which is what's mandatory for Article 33 of the REACH regulation for SVHCs. You've done what you need to do. You create the declaration of the products. Once you have that, or working version, you create the Excel version, which, what are you going to say about yourself and agree among the stakeholders? What are we going to do for safe use instructions? Do we really have to say it causes cancer, or don't touch it, or wash your hands? Well, if it's internal, you might say for internal components, you say instead should only be repaired by qualified technicians. Do not dump in the municipal waste stream, as opposed to anything around touching, because it's inside. You create the Excel versions, agree upon it, what you can do for SKUs. And you might say, hey, I'm going to make one, and then create a separate sheet saying this declaration also applies to these 15 different SKUs. You're going to have, there's a lot of keeping track of stuff. If you just start trying to do an IUCLID off the bat, it's going to be really exciting for you. You don't want to really freelance it in there. So once you're happy with your Excel version, going, okay, then you can put it in the IUCLID. And it doesn't take any significant amount of time. So there's no worry about getting the IUCLID parts done in October. There's more worry about, you know, do you have your SVHC data, for goodness sake? Because that's a lot more work. So we do, of course, product level declarations. Well, you can do it through testing. We do it through engineering evaluation. Let's look at your product together. What is this? That's nitrile rubber. It's a risk for phthalates. Do you control phthalates? Actually, yes, we're ROHS 3 compliant. Awesome. So if you're compliant with the new ROHS regulation, then it doesn't have phthalates. We don't have to put it there. You got silicone. Do you control the siloxanes in it? Normally, no. Fair enough. We're going to declare D6. If you don't want to declare D6, then you're going to have to control them. And generally, that's not through supplier, that's through testing, because the original monomer will be, the original solution before curing is well over 0.1%, and it's completely dependent on how you cured the washer. Now, if you're buying a washer from somebody, they may be able to control it, but they also have to know they have to control it, which is another problem. You create a SCIP Excel file. So once you know what SVHCs are in there, we can create the SCIP file for you. Very straightforward. Definitely, and then create an IUCLID submission. And of course, our number one recommendation is do one first. Don't make big plans when you haven't done it before. It's like me. It would be like me saying, you know what? I'm going to sew 100 outfits, and I'm going to buy all the equipment to sew 100 outfits. Have you ever sewn one? No. Might not be a good idea. Maybe I should sew one first. Or like, I'm going to invite everybody over and I'm going to cook all these different things I've never cooked before, which could work. And at least you're cooking one thing, but I'm going to cook for hundreds of people, and that's a different problem. So start with one. For example, if you've never cooked a roast beef before, it might not be a good idea to start by trying to cook 1,000 at one time. Start with one. So upcoming regulatory deadlines we mentioned, you're going to get pinged for a lot of people if they're close to in scope, needing a test report for Russia, EA, EU, ROHS. Of course, we have the subject of concern database for our next year. We have all EU MDR in May, which if you need help with that, we are really good at testing for MDR. It's one of the fastest way to meet your compliance requirements. And then, of course, next year we have the phthalates enter in scope for medical monitoring and control for ROHS. And the big doozy one for medical is cobalt, unless they change the rules, will enter into scope of regulation for EU medical device regulation, EU MDR, September, which basically brings stainless steel into regulation for EU MDR, which is going to cause complexity unless somebody sorts that out, because most stainless steel has cobalt between 0.1 and 0.2%. It's normal. Oops. And so we're in the Q&A section. I'm going to go back to presenting here. If you have any questions, please feel free to submit it in the control panel, and I'll try to get to as many as possible. There were a ton of good questions this morning. And there, I'm going to have to get into the question panel again here. Great question. Is there a grace period between when the candidate list is updated and a dossier on SCIP will need to be updated? So enforcement's at the nation state level. So ECHA can't tell you specifically, but the commonly accepted practice is 1 year. So they expect it when you do January 5th, 2021, you'll be up to January 2020 of January of 2020. So it's basically looking at 1 year. It's not official because legally it's controlled by the national authorities. We have never seen enforcement for SVHCs within the year being published. So we're looking at a 1 year grace period. And they may come out with something more explicit, but ECHA doesn't exactly control that because that's a nation state enforcement. Is the Excel sheet spreadsheet downloadable that Claigan created? We created it. But anybody working with us on any of these projects, it'll automatically be generated for them because it's just a lot easier to work with. So if we do a SCIP project for you, whether it's a testing project, engineering project, we'll always have one of those sheets. It's the easiest way to work. What do we put in for our products that use UPC codes? Great question. What is the unique one? Is it a serial code? What's the unique identifier? Is it SKU? As a pull-down menu, you can choose, but what's the unique identifier? Somebody wanted to buy it. What is the unique identifier in your sales system that says what it is, or on the box, or on the back of the product? So for CE marking, for example, CE marking is 5 marks. Most people think it's 1, it's 5. This is the CE, which has to be exact size proportions, conformité European, the actual CE itself. There's the name of the manufacturer, which has to be on the product. There is the model or serial number that has to be on the product, and that be kind of thing. If you don't have a UPC code for it, that would be what you use. The postal address, believe it or not, there's a lot of argument back and forth, but it says currently postal address of the manufacturer. And then if it's governed by a notified body, like a medical device or explosive environments, the notified body number. But that's only for things under control of the notified bodies. But things under CE marking always have to have a serial or a number on it, a model number. And so if you don't have a UPC code, that's what you use. Complex electronic products will contain discrete components in PCBAs, circuit boards. Yep. Some of the components will contain lead and solder. Yes. Do we have to report these discrete components in SCIP? Yes. So lead is an SVHC if in a metal or metal alloy. So lead is reportable. Lead in brass is reportable. Lead in aluminum is reportable. Lead in steel is, so all those 6A, B, and C for ROHS. Exemptions are all reportable. Lead in glass is not. It's leaded glass. It's a different CAS number. So, for example, your thick film resistors will have a leaded glass layer. Sometimes listed as lead oxide, but it's actually been agreed upon as leaded glass and not declarable. So lead in the glass is not lead metal. It's a different CAS number, different chemical number, different EC number. Lead high temp solder on your components would, as would be if your product does not have to be ROHS compliant, use leaded solder, the lead solder. But normally what we do is we list lead in solder, or lead in high temp solder, and then how many components have it, and close enough. As long as we identify high temp solder and say any individual product may vary the number of high temp solder parts it has with the SVHCs, we'll say high temp solder, best estimate is 5 parts. Then you have to list this. The lead solder, whether it's because not ROHS compliant or because you use high temp solder, so exemption 7A for ROHS has to go in there. Great question. If the product has several different sizes of brass standoffs, so different part numbers, would you recommend creating separate articles for each size? No, I would. Then, as long as they're all the same customs code and their lead falls under the same pull down menu range, I'd put them all together. If they're separate saleable items, like you have to sell repair parts, you'll have to create separate part, you basically go part number listings for them, but I have all of those listings point back to the same generic declaration. So we would not normally create different listings for any different sizes. We just have it all the same generic. Is it same custom code? Yes. Same lead range? Yes. It's brass? Perfect. We'd have them all list the same thing. Can you confirm the military product is exempt for SCIP? Yes and no. EU legislation cannot govern the national security of a member state. So a member state can choose not to have a CE marking legislation apply to its products. So military products can be chosen by the member state to not comply. However, in general, they don't do so. So in general, and if you sell into military, they ask for the SVHC information. So they're not by default excluded, but they can be chosen to be excluded by the military. So the military buying the parts can exclude them from REACH SVHC, but it's a choice of the military. If it's governed by their national security, they can choose to omit it. But otherwise, it's de facto wings. They have to choose to omit it. So military is in scope unless somebody chooses to omit it. What do we have to do if the REACH SVHC declaration or volume is under 1 ton? There's no tonnage basis for SCIP declaration. Is that SKU have it? It is no tonnage. There is a notification requirement if you go over 1 ton and the use is not included in its dossier registration, which in almost every case is the lead and high temp solder, the lead in touchable parts, the lead non-touchable parts. That's already covered in the REACH registrations. So you don't have to notify for them. So if you go over 1 ton and it's in a use that's not registered for that chemical in its known uses, yes. However, almost every single SVHC situation is registered for that. It's already registered for that use, so you don't have to do anything. And SCIP has nothing to do with tonnage. If that unit has it, it has it. And it's only whether or not a component is over 0.1% by weight. Now, if you sell it, if you send an item, one item once ever, and you don't have an SVHC declaration, there's really no penalty for one item. Any penalty is usually related to volume. So if you do one item once, I wouldn't get too bent out of shape about it. But units you sell regular, there's no volume levels. If we sell components to non-EU customers, but they are integrated in products going to the EU, do we create a SCIP entry or just apply our declaration to the system integrator? So legally, you don't have to do anything. But that would also apply to ROHS. So they need the information to be compliant. So you only would have to supply a declaration to them. You could put your product into SCIP, but you don't have to if you're not bringing it to Europe. And if you do, they may want to link to your product. That's a make work project for them. I would not do that. However, on the bright side, if you create a SCIP declaration and your customer links to your product, it makes it extra hard to get away from an extra barrier of them not using your product in the future, because they have to change all their SCIP and compliance information if they stop using their part. So there's advantages to it. But if you're not selling the product in Europe, you don't directly have to do the SCIP declaration, but they might need the information, usually a paper declaration, to do theirs. I have an off-the-shelf resistor on my product. Do I have to do a separate submission on it, or can I link it to the submission done by a supplier of the resistor? You can do both, but unless using lead solder, it's not declarable, SVHC. I would not link to the submission of the supplier because your resistor is a jelly bean part for the most part, and there could be 3 alternative suppliers for it. Why, if it was leaded resistor, using lead solder on, I would actually just create one for lead solder because the board's leaded and just have a lead solder listing. And lead oxide in a resistor is not an SVHC. It's leaded glass. What do you recommend as best practice to mask certain component information competitive advantages? I would normally just create generic parts, not just for competitive advantage, just because it's blooming easier and a lot clearer for the customer. I wouldn't say, hey, it's part number XYZ from supplier ABC. I would just say it's a brass component. And that's that. If SDS indicate an SVHC when the final cured form is consumed during curing, it's still required to input an SVHC in SCIP. SCIP does not care what is in the original safety data sheet. All it cares is what's in the finished article. And not only is the cured form usually have a lower solvent like NMP or a monomer like T6, it's often coated onto something. And once you coat a chemical onto another thing, its SVHC is calculated over the weight of whatever it's coated onto, which usually drops its concentration dramatically. So if it's on the SDS, that's an awesome starting point, but it often doesn't mean it's declarable at all. We use an ODM for our products. Can we use their SCIP report? Nice thing about SCIP, unlike any of the others, there is no specific person that has to register. Anybody can. So as long as somebody puts a SCIP declaration in, whether they put it in and you use it, or they give you the information to make your own, or your distributor submits it, it's all fine. It doesn't actually, as long as a product has, for their unique product identifier like UPC code, has a SCIP, then that's all it needs. We had some good questions, also adding some good questions from this morning. They're asking about coatings, which you just talked about. We have, do coatings have to go in the into SCIP? So the rule is any SVHC in a component about 0.1% by weight means the product and its component has to go in the system. A coating is a chemical until it's coated on. So you don't calculate the weight of an SVHC until after it's been applied. It's at the point where it no longer requires a safety data sheet. And they can go to the very metaphysical about really small things. But or say for a resistor, in theory, you put coating on after coating, and what time is an article? We just say the resistor. Each layer in the resistor was a chemical until it made the resistor. So any SVHC in a coating is, or in a layer in the resistor, is measured over the weight of the resistor. Same thing with a metal part where you have paint, and the paint, one, can have TGIC in it if it's powder coated, and the TGIC is also heavily volatile. So not only will it not be there mostly in the final coating, the coating on the metal piece, any SVHC in that coating is measured over the weight of the metal piece. Same thing with adhesive. I have two things, and I put Loctite or some other adhesive to join them together. Any SVHC in the adhesive is measured over the weight of the two things combined that it just put together. However, if one of the things put together is a brass component and it has an SVHC in it, but 0.1, it's declarable over the component before being joined, because when it was a physical part, before you glued them together, it was still an article. And so it's legally, it's at the declarable spot is if it's over 0.1% by weight, the SVHC, in the first time the item you're talking about no longer has a safety data sheet. So once it's an article and no longer is governed by a chemical safety data sheet, that's the article level. And so it's a good question whether the SVHC is above 0.1% by weight. So the adhesive, it's governed by safety data sheet until the point where you glue two things together. And then it's not governed by a safety data sheet anymore. It's a physical article. But the article is the two things glued together and the adhesive. So any SVHC that remains in the adhesive is over the weight of itself and the two things that just glued together. Same thing with paint. It's over the weight of whatever's painted on because there's a safety data sheet right after the point where it's painted on. You get to very metaphysical things where you have flexible circuit board where you can theoretically have DMAC in the circuit board just over 0.1% by weight, but is the flexible, but there's copper tracing, and most people identify the copper tracing as part of it. And so any DMAC is over the weight of the flexible material and the copper tracing. When you get to something that small, close enough is fine. If somebody gets that picky, we'll have a good conversation about it. One of the most common SVHCs and the third most heavily enforced SVHC is ADCA. That's what, if you do the on-site, we explain things like that. It's how you make closed cell foam. So foam, in a lot of ways, is like bread. When you make bread, I apologize, I'm going over time for people, but people often have a lot of good questions. If you're making bread, you often put yeast in it. What yeast does to make it rise is it eats the sugar and warm and releases carbon dioxide, makes little carbon dioxide bubbles. And the bubbling or the foaming of the bread is the bread rising. So the bread rising is actually the bread foaming. And then you cure it, i.e. you bake it, and it cures in the bubbles. So for closed cell foam, so cell foam you can't blow through, it uses ADCA, and it consumes consumes water, and with heat, it creates nitrogen bubbles and a little bit of CO2 bubbles, and it bubbles or foams the polyethylene, and that creates like the closed cell polyethylene foam, like your pool noodle. So if you take your pool noodle, which is a closed cell, and you try to blow through it, you'll just go blue in the face. Those are closed cell, air won't pass through it, and those cells are created by ADCA. And that's usually residual. So one of the most commonly enforced SVHCs is actually what creates closed cell foam. Your polyurethane foam, like in your furniture chair, is open cell and doesn't use ADCA for the most part. Another funny thing is where you see ADCA in North America is in flour. Yep, because when it gets warm, it releases nitrogen bubbles and gives you a little bit of extra rise. It's always surprising where wait a minute, I can see a REACH SVHC in the flour bag I'm buying. It's right there in the ingredients, which is fine as long as you don't inhale it. ADCA is only an inhalation risk, which seems like a big problem with flour in my point of view. So that's most of everything. If you have any more questions, you need help with SCIP, we're pretty darn good at this. Engineering, evaluation, or testing. Definitely recommend doing one first, and then don't try to do 1,000 or try to find the solution somebody's going to fix all your problems. Do one first, and then start figuring out where you're going to go from there. Thanks everybody for attending again. Everybody who registered will receive a copy of the presentation, hopefully with the fix I'm going to make, and with that one line above. And then there should be a recorded version available on our website in a couple weeks, hopefully, or a couple days actually, and should be hopefully in YouTube also, where you can scroll down to 70% speed and I can make a little more sense. My mom has some concerns that I'm nonsensical, which is fair enough. Yeah, no, it's worked out for me most days. Thanks again for attending, and I look forward to talking to everyone again soon.